Welcome to this webinar where we're going to be looking at this clever little device here today, which is our transformer monitoring solution. And this is a device which we call Connect UMG. And a little bit of housekeeping before we start. If you're looking for this video in German, we already have it available online on our YouTube channel where my colleagues have already gone through this. So please go there if you're looking for the German version. This is for our international customer base, all being done in English. So let's make a start. So what am I going to be covering today? We're going to start by just a quick reminder about what SMIGHT offers and how our system until now has been working and where therefore the Connect UMG fits in, just to give you a bit of context. Going to have a little bit of a look at why we want to do transformer monitoring at all. So we come from a background of doing feeder level monitoring. So it's an interesting question, why would you start wanting to monitor transformers? So we'll look at that. Then we'll look at the device itself. This is what it is physically, but actually looking at how it works. And then we'll go on and look at how the data is being represented in our SMIGHT IQ system. And finally, I picked out a few of the questions that we had in our German webinar as the questions the audience of this webinar might have, as well as a few FAQs at the end. So let's start off, as I said, with looking at who we as SMIGHT are. So as our background, we came from within the Janitza BV network operator. So they're one of the larger network operators in Germany. And they came to us with the question or the challenge saying we've got about 30,000 substations out there which need to be digitized. You guys know a lot about IoT technology and we're looking for a solution. And out of that was born SMIGHT's product as it is today. But now, even after a relatively small number of years, we're being used by over 130 network operators across Germany and a few bordering countries. We have our system being used in over 5,000 substations, and that equates also to 40,000 feeders being measured today in our system. We don't really want to say, oh, aren't we big and wonderful? We're really trying to get across the point. This isn't a prototype idea that's a nice idea on paper. It's actually a real system that's being used by many network operators and being used in a large volume. It's a system that works. And we've brought a few of our customer logos here just to demonstrate how this could be a large city setting, it could be a rural network, small towns and everything in between. Is really the areas where it can work. It doesn't matter what type of network you have, being able to monitor your network is important, and that's where we really come from. Most importantly, more recently, we've got our ISO 27001 certification, so you can be sure that everything that we offer is fully conformed to the security standards for data handling. At the moment, our product offering is very much oriented around feeder level monitoring. So we're talking about low voltage feeders within secondary substations and or distribution cabinets. So we do that with our sensors, which we put onto the feeder cables, one for each of the 3 power phases, but also for the neutral line. So we're taking those 4 phase measurements. We're measuring the current flow direction and magnitude, but also the phase angle. That, as a piece of data, is then being transmitted via Bluetooth to our gateway. So that already makes it a particularly simple and clean installation because there's no cabling running between the sensors and the gateway. Then the gateway is taking a single voltage measurement from the bus bar and combining those 2 pieces of data and then sending those up into the cloud via the mobile networks. So you get this kind of key information from the feeder level of what's the current that's flowing, which flow direction do I have, what's the voltage level at the feeder, and then also getting all of that up into the cloud. So that's our kind of core principle. Once it's in the cloud, we offer a visualization of that data through our own platform. That's all included in the package, but we also offer the API available to take that data out into other people's systems, so your data is never locked up with us. And the other point we always like to get across with this slide is that we have the arrows going in the other direction as well. And that's there to represent that we offer a managed system. It's fairly easy to go out there and install sensors and gateways and buy server space. What's actually quite difficult to do is when you have thousands of little computers out there, is to keep them up to date, keep them secure, make sure that all the communication is always working, but also make sure that the installation goes smoothly. And we offer this as a complete package to make sure that these can be rolled out very quickly, but easily, and that they always function as they should do. So that's really our kind of core system. And the device that I'm talking about today, the Connect UMG, is really in addition to this on the sensing end of the spectrum. So how do we look at this in terms of our overall structure within SMIGHT? So we have this kind of level where we talk about the devices that we provide for capturing data, and that's where the level that we're working at today, which is just an addition to that range to capture the transformer data. Then we go on to say, well, we need to understand the data. Data sitting in a server somewhere is no good to anybody. You need to be able to use it, and we put lots of emphasis in our offering on that. So the data that we're talking about capturing today lands in the same place as the data that we're capturing from feeders. And the idea that we try to get across to our customers and what we see actually being used out in the field is this idea of going around this circle that we have here. So the first step in the process is really to understand, where have I got critical points in my network? So you usually start from a place of you don't know what's happening in your low voltage network because you haven't had a monitoring solution. So the first step is you're starting to gain transparency and understanding of what's happening, and through that you'll start to see critical points in your network, whether that's voltage deviations or it could be load situations, it could be solar feed in, whatever it might be, you're going to find these critical points in your network. From that, you can then move on to saying, well, I've found where I've got critical points, and through that process you've probably also learned to understand what capacity do you have, so what headroom do you have in your network. So looking at where your capacities are in the network, you can then usually use that capacity more sensibly. And it could simply be that one feeder is overloaded and the one next to it has got capacity on it. Depending on the topology that's sitting under there, you might be able to take that across, or it might be that one substation is overloaded and another isn't. And again, changing the topology out there might mean you can share that load. So you can go through this phase of trying to deal with those capacity issues through existing infrastructure. But at some point, you're going to reach this stage where you're going to need to upgrade what you have out there, whether that's a new feeder, whether that's a new transformer, whether it's additional infrastructure, you're going to need to perform upgrades. And then it's useful to know what order to do those in. So it's not always the case that you want to change out the oldest transformer or the oldest cable first. It maybe makes sense to do them in load order, or where you've got the most critical situations, or where you can reasonably expect the load growth to happen fastest. So you then go through a phase of performing upgrades. And then lastly, we see the data being used in grid simulation, state estimation, and so on, to actually try and predict or try and understand in bits where you're not measuring in the grid what's going on. And that in turn will uncover further critical points, either today or potentially at some point in the future, and then the circle goes round again. So it really is a case of using that data to understand your network planning, and also your asset management to really make that process a bit more informed. And the final point, just to have it mentioned, it's different in different countries, is this point of control. That once we get to a point of understanding what's happening in our low voltage grids, which is what we're trying to do here, eventually you're going to get to a point where you're going to need to control what's happening in those grids. Every country is looking at this a little bit differently. In Germany, we have the paragraph 14a regulation, where network operators can actually control loads in the grid. In other countries, this is maybe done through flexibility markets or other mechanisms, but really there is this step which we provide the interface for, is how to interact with these third-party systems that are trying to control what's happening in the network. So really about capture the data, understand what's happening, and then also execute control signals out in the market. And the level that we're thinking about today is this capture. How can I capture data from the transformers out in the field? Okay, so as you can see, where we've come from is very much this feeder monitoring background. This is where we started off. And so there's a really key question here: why perform transformer monitoring at all? I have a good phrase in English: horses for courses. The idea being that you need to have the right tool for the job. So there's going to be, it's not a case of do I do one or the other, it's a case of in which situations do I use one, in which situations do I do the other, or maybe what mixture of the two makes sense. I just quickly want to run through where you would use which for which purposes. So starting with feeder monitoring. So feeder monitoring gives you just simply a much higher granularity. So you can imagine you have your transformer station, you have a transformer, and you maybe have anything between, say, 4 and maybe 10 feeders coming off of that. If I can measure, say, those 7 feeders coming out of there, and I can understand what the load distribution is across those feeders rather than the single point of the transformer, I have a much better granularity of information about what's happening in the network below that. So that's the first situation, is where I need high granularities. Feeder monitoring, the better solution. The other thing is some of the critical points might actually be further out in your network. So transformer monitoring can only be done at the transformer, but sometimes I want to know what's happening at the end of a voltage line, at the end of a feeder, and that's particularly important for voltage. So the voltage that you're seeing at the substation is going to mainly be dictated by the medium voltage. Whereas if you've got solar feed-in, or if you have particularly high loads, your voltage drop or your voltage rise, you're going to see at the end of the line. And so it can be very useful to actually take those measurements further out in the network. And so that's where feeder level monitoring can really be very useful, is when you want to take those kind of level measurements. Next, it's important to bear in mind, people get mixed up with this, is that just because I have a low transformer load doesn't mean I have a low feeder load. So you can imagine a situation where I have a transformer that's maybe sitting at 30–40% of its capacity. That would be something you wouldn't be worried about at all. But all of that capacity could be sitting on 1 or 2 feeders, and those feeders could well be well outside of their capacity or very close to their capacity. So if you come from a background of monitoring transformers and you think you've got a good overview of what's happening, it could give you a false sense of security without having the feeder level data. So in those situations, especially with more feeders, it's really important to be able to understand what's happening at the feeder level, because your transformer just simply can't tell you that. So another way around of looking at it is where the transformer capacity exceeds the sum of the feeders, it actually is not interesting to monitor the transformer, i.e. if I know the transformer's overloaded, it's way too late. If the load that's sitting on the feeders is more important, you have to start measuring them. And the kind of situation where that might happen is that you might have built the transformer well in advance of what you expect to happen, but the individual feeders may be overloaded already, and therefore you need to monitor those feeders as the first point of contact. And then the final point here is really about the heterogeneity of the customer base. If you have what normally happens in the energy transition is that you have particular types of customers clustering together. It might be a street that's been newly built or has a generation change happening, is more likely to maybe be exchanging gas heating for heat pumps, or might be more likely to have EVs, or might be more likely to have solar installations. And so if you look across your network, where things are changing and starting to happen will not be happening evenly across all feeders. And that's where the feeder level monitoring again really comes into its own, is you can monitor those bits in your network where you've got the most dynamic change happening, or the highest load growth essentially. So those are the kind of areas where feeder level monitoring makes the most sense. So what's the flip side of this? Where does transformer monitoring make the most sense? So it makes more sense in substations where you have a low number of feeders. So there are plenty of situations out there where you maybe have just 3 feeders coming off of a transformer. In that case, the level of differentiation between those 3 feeders may not be that relevant, especially in relation to the size of the transformer. So it might make sense saying, okay, if I measure that transformer, that's enough for me to be able to tell what's happening below that point. So if you're looking at more the smaller transformers within your network with low numbers of feeders. And then where the transformer capacity is significantly lower than the feeders. So you can imagine a situation where over time the number of feeders has really grown, and each feeder maybe has been laid with the right level of capacity, but just that simple growth in the number of feeders has meant that the size of the transformer in relation to the feeders has just got out of balance, in which case it makes more sense to monitor the transformer. That's probably going to be your weakest link in the chain. And though whilst you may have many feeders and it may be interesting to understand what's happening on them, it's actually the transformer that's actually the critical part that you need to monitor. So in such a situation, it would make more sense to monitor the transformer. And the other thing is, this is a retrofit solution. So if you have these Janitza devices already in your network, you can have a very simple small device added onto those to suddenly make your transformers come online, essentially making that data live. So if you've already got these out in your network, it makes a lot of sense to start here, because you've already got the monitoring happening. It's just not live data that's being processed, it's data that's being captured in situ but not being transmitted out. And so it can be a very quick way to start to get a live network overview if you've got these devices already. And then the flip side of the heterogeneous situation is if you have a homogeneous customer base. If you happen to have a situation where you say, all the feeders, the nature of what's sitting on all of those feeders is very similar, you can actually save in terms of the volume by actually just monitoring transformer and say each one of the feeders is just a fraction of that transformer load. So that may be reasonable if you have such a situation. And then there's the topic of total harmonic distortion. That's only possible through this device. So if that's something that you're interested in, then we can only offer that through this. When you're starting to get into more interesting power quality metrics, then this is the only way that we can offer that at the moment. That would be one use case. And then finally, it's more cost effective to be able to do it this way. So a single transformer monitor is less costly than, say, 7 feeder level monitors. So if you're constrained on a budget level, this would be a good place to start, and it may be able to help you define where you want to do feeder level monitoring. So I hope that's given you a bit of an idea of where you'd use one over the other, and it may be that you have a network that's predominantly one or the other, but it's more likely to be you'll have different areas of your network where these will make more or less sense. You can then decide where you want to roll out which technology. So now to look at the devices themselves. So, as we mentioned before, these come from the company Janitza, and the devices that we're talking about are these 3. So these are the UMG 96, the PA, the PQL, the PQL-LP. So these are the only devices in the range where this is possible, and the piece that makes it possible is this slot on the back. So the device that we provide is this. This is a Bluetooth communication module, and it slots into the back of this device. And so these are the only devices within Janitza's range where you can have that. And if you want to know anything more about those, then please visit Janitza's website where they have more details about those. So let's have a little look at what we're measuring and how this works. So the core measurements that we're taking out at the moment are 3-phase voltage. So again, that's a difference to our normal standard setup. So our gateway normally takes 1 voltage. So if you're interested in looking at the 3-phase voltage, this is the best way to do it at the transformer level. The 3 current phases, the phase angle, then we've got power and apparent power, so that's new because we weren't measuring power before. Then the total harmonic distortion, both in current and voltage, again, that's new in comparison to our feeder level monitoring. And we've integrated this into our installation process on here, just like on all of our devices. There's a QR code which gets scanned during the installation via our app, just to make the installation very quick and easy. If you don't have these devices already, we have them in this SMIGHT look, with the SMIGHT colour on the front, where you can buy the device as a complete unit from us as well. So now to give you an idea of what that installation looks like and how easy it is, we prepared a video with one of our customers. I'll play that for you now just to give you an idea of how quick and easy it really is.
Dies ist unsere Produkterweiterung SMIGHT Grid2 Connect UMG. Dieser Adapter ermöglicht es, Janitza UMG 96 PQL Trafomessungen in unsere SMIGHT-Umgebung zu integrieren. Heute zeige ich euch gemeinsam mit Niklas von den Stadtwerken Frankenthal, wie man das SMIGHT Grid2 Connect UMG einbaut und in Betrieb nimmt.
So hopefully that video has given you an idea of how quick and easy it is to install, and anyone who's used our devices in the past will be familiar with that process of being able to quickly scan and get the devices live and up and running. So now I'd like to move on to looking at what does the data look like when it arrives in the SMIGHT IQ Cockpit. So this demo is available on our website. So if you go to our website, you can actually click through and view all this data yourself. Again, as a quick overview of what's the overall concept here. The overall concept is to give our customers a very quick overview over their network, to do that first step in the process, that finding critical points in the network. So you have a map with all of the points where you have SMIGHT devices installed. Each one of these pins represents a gateway, whether that's in a secondary substation or a distribution cabinet. You'll be able to see those. You can see critical events that have happened and other information. If you want to look at the Janitza data that we have represented here, in the top left pin that you can see on the map, that's the one that you want to click into to be able to see this data. And in here, again, as a brief overview of what this system's showing you, this is giving you a substation overview. On the first view, I can see that there are 2 transformers in here and 2 low voltage panels, which I can see down here. Normally, without the transformer monitoring, you'd probably be most interested in what's happening at the feeder level, but for what we're looking at here, we're interested in the transformers. I see those here at the top. When I click into a transformer, I can tell that a Janitza device is connected because it says up here that the transformer power is measured, so it's not being calculated or anything like that, it's measured power. I can also see that I can look at the load and the voltage all together. So that's how I know that I'm looking at a device with Janitza data. And then we get our time series looking at the power. I can toggle between or have both, filter in and out basically the power and the apparent power. I can look at load. Again, I can toggle in and out what I want to look at here. Am I wanting to look at just maximum values, minimum values, means, specific phases? It's really simple to take these in and out simply through the tick boxes that you have at the top here. And likewise, I can look at the voltage level. And then if I want to look at a particular thing that's happened, to zoom in time-wise, I just click and highlight the area that I'm interested in, and then it will zoom down into that. So I can go from this kind of high-level view of where have I got critical points in terms of substations or distribution cabinets, down into what's happening within that distribution cabinet or substation, down into what's happening minute by minute, phase by phase, and the different parameters that I'm looking at. So I can go from it's critical to what is critical, at what time, what's the nature of the criticality, so I can actually then do something about it. So that's really how the data is being represented. Now, if you remember, I was talking about total harmonic distortion, and you can't see any of that here. That's one metric that we're measuring, but we haven't found a way of displaying yet. So that would be included in the kind of reporting that we provide off the back of this, but it's not something that you can see on our front end. So finally, just to wrap up, we've got the few questions that were asked during our German webinar that I think will probably be relevant. So the first question that we got was, can I read out all of the data that the UMG device is capturing? So it's important to note that that table that I showed you before of the things that we're reading out is not everything that the device is collecting. It can collect a whole lot more data. So the answer to this question is no, we're not reading out everything. We've kind of picked out the core critical values that we think are relevant at this point in time. There's a lot more data that you can get from the device and it's storing itself and that you can use in the kind of Janitza world. That's all still present and available to you. If there are other pieces of data that you're particularly interested in, then talk to us. It's all something that we could read out from the device in the future. Then the next question was, following the installation, can I see that the Connect UMG device is properly working? Can I do that in situ? Because I don't want to find out that it's not connected properly when I get back to the office. And the answer is that on the actual device, one can actually click through on the menu system and see that the SMIGHT Connect UMG device is correctly installed. It will have a serial number on there and it will show that it's connected and working. So the answer to that is yes, and it's through the interface on the Janitza device that you'll be able to see that. And is it compatible with other Janitza devices such as the UMG 801? And the answer to that is quite simply no. The 3 devices which I showed you before in the presentation, those are the devices that we're compatible with at the moment. I'd say that this is just our first start. What we're essentially doing is reading out the Modbus connection, and we could do that for other devices. So we're obviously thinking about how we might do this for other devices in the future, but for the moment it's limited to the devices which I listed earlier. And then final question was, can the Janitza device still be used as normal? And the answer is yes, to a point. The only restriction you have is because this is in this slot on the back, any other module that you might have for here can't be used because the slot's being used. But in principle, all the functionality that you have with the device, its ability to communicate and be read out by other systems is all kept and it all continues to work. So yes, to a point. Okay, well, thank you very much for watching this webinar. If you want to find out more information, here are a few points to start. First of all, our website, where you can find out more details about this device and all the rest of our products. The Janitza website for any of the Connect UMG devices themselves. I would encourage you to sign up for our newsletter where you can get all of our latest updates, our LinkedIn channel. If you follow that, you'll also get all of our latest updates, what we're doing as a company and when we're releasing things. For videos like this and other explanations, webinars, product demonstrations we have on our YouTube channel. And if you want to get into contact, we've got our email address, telephone number there, and yeah, we'd welcome contact from you if you'd like to do transformer monitoring in your network.